Hi everyone, Miss Andronicus here, and today we are looking at compound measures. So a compound measure is one that involves two different quantities. So you've got kilometers per hour, meters per second. Average speed is an example of this. You've got distance and you've got time, and as I had just given in the examples, many involve the word per. This tells you that it's one quantity divided by another. Have a think. Can you think of any other examples? So often graphs can be used to demonstrate two different quantities. Let's have a look at this travel or distance time graph. You can see the distance is on the y-axis, you've got the time going across the x-axis. This graph displays a cyclist's journey in a day. So as you can imagine, the distance indicates how far from home this particular cyclist travels. And you can see that he spends all of this time going away from home, and then he turns around and he comes back. So this is the distance from home or wherever he may start his journey. So when we have a look at this travel graph, we can see that it's distance and the time it takes him. So that is moving at a constant pace. If he's spending time not gaining distance, that means he's stopped cycling. He's resting or has stopped for whatever reason. And then he continues, and then again he stops, and then he cycles. So you can see the steepness. Obviously, the steeper the line, which is the higher the gradient, the faster he is going or she is going. Now, this particular type of graph can come with any number of questions. When did the cyclist leave home? When did the cyclist return? How far away from home was he at any one of those times? How long was this journey altogether? At what times did he take a rest? How far away was he at noon? Find the speed at this time or at this time. When was the cyclist traveling the most quickly? There's so many different types of questions that can be asked with this. Let's look at some example questions. So, for example, how fast was the cyclist going between 8 and 10 a.m.? If you have a look, you can see that constant speed from 8 to 10 over those 2 hours equals a distance of 20 kilometers. If over 2 hours he was going 20 kilometers, then in 1 hour, divide everything by 2, it must have been 10 kilometers. And you know that speed is kilometers per hour. So in 1 hour, 10 kilometers, therefore it's 10 kilometers per hour. And that's how you could then go and find any one of those speeds. How fast was the cyclist traveling from 11 till 2, for example? Okay, same thing. How fast was the cyclist going all the way home? You need to recognize that it's from 3 till 5. The steepest portion, the faster the cyclist is traveling. That's just one example of question. Another very common question is find the cyclist's average speed for the entire journey. So you would need to have a look at all of the hours that this cyclist is moving, first of all. So this rest hour and this rest hour does not count. So you would have a look at the entire day and then, of course, take off those 2 hours of rest. So that would be 7 hours of travel. Okay, 7 hours of travel, fine. And how far was the distance over those 7 hours? So you can see from the distance and the height that this cyclist went all the way 60 kilometers away from home and also traveled another 60 kilometers back home. So there was actually 120 kilometers for the distance. So you've got distance you've got time. So the average speed equals distance over time, which is 120 divided by 7. And I've gone and put that answer there, 17.14 kilometers per hour, rounded, of course. Now, another question could be very much like interpreting the graph. So give a possible reason why it took this cyclist so much longer to go away from home and so much faster to get home again. I mean, it took all these hours to cover the 60 kilometers and a rest, and then in the afternoon, 2 hours. So suggest a possible reason for this. Now, a possible reason could be the fact that perhaps this cyclist was climbing a very steep hill, for example, and therefore needing a bit of a rest, and it took a lot of time. And then on the way back, the cyclist was going downhill, so therefore it was much, much faster to get back home. That's a possible reason. So sometimes you need to also interpret these graphs as well. Distance time graphs can look very different sometimes, so you've got to be really aware of the scale that is used. So in this example, that double spacing is just 1 hour in this instance, so you just need to be really aware of the scales. And lastly, you can have obviously multiple bits of data on it. So you can see here you've got 2 cars traveling at a speed of meters per second, and then you've got the time in seconds. So then you can sort of see the journeys and how fast, let's say, a car was traveling. So lots of questions again can come from these types of graphs, and you just need to keep practicing them. Okay, that's it. Thanks, guys.